Have you ever wondered why some arguments completely fall apart under pressure, while others just seem absolutely unshakable? Think about the debates you encounter every single day. Usually, an argument doesn't fail because the core idea is inherently wrong. It fails because it's structurally unsound. It just lacks the right support systems. Welcome to this explainer. Today we're focusing entirely on the architecture of logical design, and we're looking at an incredibly powerful blueprint known as the Toulmin model. So if you want to build ideas that actually stand up to scrutiny, you're in exactly the right place.
Okay, let's dive into this. Here's our roadmap for today. We're going to cover the architecture of arguments, the 6 Toulmin components, a case study on green roofs, another case study on historic preservation, and finally, argument mapping and logic. Let's get to it.
Part 1. The architecture of arguments.
We can draw a really direct parallel between physical architecture and the architecture of a debate, and that's because the underlying principles of stability and support are surprisingly similar. Think about it. Just as a massive physical building absolutely needs a solid foundation and load-bearing walls to stand tall against gravity and wind, a logical claim needs a rigorous structure to hold up against skepticism and scrutiny. And that is exactly what the Toulmin model gives us. It's a structural framework that lets us deconstruct and build logical arguments, breaking them down into distinct interlocking components. It basically forces us to see how every single piece of an argument completely relies on the others.
Part 2. The 6 Toulmin components.
So what exactly are these building blocks? Let's look at the raw materials you need to construct a truly bulletproof argument. Based on our source material, the Toulmin model breaks down into 6 vital elements. Think of these as the concrete, the steel, and the load-bearing walls of our logical structure. First up, we have the claim. This is the main assertion you want to prove. Second, we have the grounds, which are the data, evidence, and specific facts serving as your foundation. Third is the warrant. This is the logical link, the assumption that connects your grounds to your claim. Fun fact for you, missing warrants are actually the #1 reason everyday arguments completely collapse. Fourth is backing, which provides specific justification for that warrant. Fifth is the qualifier, which sets the limits of truth using words like some or presumably. And finally, number 6, the rebuttal. This is where you acknowledge valid opposing viewpoints.
And this brilliantly illustrates the framework. If you look at how these pieces fit together, notice how the grounds act as that foundational starting point on the left, and they lead directly to the claim on the right. But look at what actually holds that connection together. The warrants sits right there in the middle, pushing up from beneath, supported by its backing. Then over on the right side, the qualifier and rebuttal are attached to the claim. They act as structural tolerances, basically defining exactly when the claim is valid and when it isn't. It is a complete functioning logical ecosystem.
Moving on to Part 3, Case Study, Green Roofs.
Now that we've got our abstract blueprint, it is time to shift from theory to practice. Let's stress test this blank framework with a real architectural debate. Here's a question I want you to consider. Should green roofs be required for all new commercial buildings? Take a quick second to formulate your own messy, instinctual argument. What's your immediate stance? What reasons jump into your head? Hold on to those thoughts, and let's see exactly how the Toulmin model organizes them.
Now, what's really interesting about this slide is how that abstract diagram fills in with concrete architectural data. The claim up top is our mandate. Green roofs should be required for new commercial buildings. To support this, we look at our grounds on the left. Green roofs can help reduce a building's carbon footprint through energy efficiency and mitigate urban heat island effects. But how do we get from that data to our mandate? Right, through the warrant. The warrant is, by providing insulation and natural cooling, green roofs lower energy demands. And we back that up with specific studies showing a 10 to 15% decrease in energy usage. See, we've built a solid, logical path straight from the facts to a policy recommendation.
But listen, a truly strong argument doesn't just ignore reality. The real strength of the Toulmin model isn't just in making some bold claim. It's in acknowledging its structural tolerances. As our source highlights, we absolutely must include the rebuttal, noting that initial installation costs for green roofs are higher than traditional ones. And we also have to include the qualifier, admitting that the benefits might vary depending on the building's design and location. By outlining these limitations up front, the argument doesn't shatter the second it's challenged. Instead, it flexes, and it survives.
Part 4, Case Study, Historic Preservation.
This time, let's see how the model handles a slightly more philosophical debate, one that pits cultural heritage directly against modern development. Think about the tension we see in growing cities all the time.
Should historic buildings be preserved through renovation instead of being demolished? It is a classic clash. You've got the desire to maintain a cultural sense of place on one side and the practical economic realities of urban development on the other. So let's map it out.
So the crucial point here is how the underlying philosophy acts as the glue. Our claim is that historic buildings should be preserved. Our grounds point out that renovation conserves cultural heritage and reusable materials. But look closely at the warrant bridging that gap. Preservation of historic architecture is important for maintaining a sense of place and continuity in our built environment. That is the assumption, the logical link, that validates moving from the facts of conservation to the actual demand for preservation. If your audience doesn't accept that warrant, well, your whole argument crumbles.
And once again, the model forces us to be incredibly realistic. Look at the qualifier provided in the source material. In some cases where repair costs greatly outweigh benefits, strategic demolition may be preferable. In architecture, just as in logic, acknowledging opposing forces prevents the entire structure from collapsing. Because if you claim that literally every single historic building must be saved regardless of extreme repair costs, your argument becomes rigid. It becomes fragile. The qualifier is what makes it resilient.
Finally, Part 5, Argument Mapping and Logic.
In this final section, we're going to zoom out a bit. We've seen how individual arguments are constructed, but how does this Toulmin model fit into the wider, overarching world of logical reasoning? Well, as our source notes, logic typically divides into deductive and inductive reasoning. Deductive flows from the general to the specific, aiming for absolute certainty. Basically, if the premises are true, the conclusion absolutely must be true. Inductive reasoning, on the other hand, flows from specific observations to general probable claims. And this is exactly where the Toulmin model really shines. It's perfectly designed for mapping inductive, real-world arguments where absolute certainty is pretty rare, which is exactly why elements like qualifiers and rebuttals are so absolutely essential.
Let's trace that visual path. Notice the differing flow of reasoning here. On the left, inductive reasoning moves upward. You go from a specific observation up to a pattern, to a hypothesis, and finally all the way up to a general theory. Conversely, deductive reasoning on the right moves downward. You start with an established theory, move down to a hypothesis, make an observation, and end with concrete confirmation. The Toulmin framework helps us navigate these pathways safely, ensuring we don't just jump to conclusions without the requisite backing. But what happens when things get really complicated? Right, because a single Toulmin claim rarely exists in isolation, let's move to and see how this builds. As shown in this argument map, the main claim sits right at the top. But below it, you can branch out into a massive, multi-level web of subordinate arguments, reasons, specific evidence, and various objections. By using labeled lines, like support or oppose, you create a comprehensive visual diagram of an entire debate. You can track exactly which piece of evidence supports which warrant and which rebuttal attacks which claim. It's like a giant puzzle.
Ultimately, whether you're debating green energy mandates, urban preservation, or just everyday business decisions, the core principles remain identical. A bulletproof argument requires a solid foundation of grounds, the structural support of well-backed warrants, and the flexibility of qualifiers to withstand the pressure of rebuttals. So the next time you find yourself trying to persuade someone, take a step back and look at your own logical architecture. Are your ideas just a pile of loose bricks, or are they truly built to last?